Right. We're live for day 19 of AppNetCode 2024. About 20 minutes left. So we're going to go over some practice, warm-up problems. And every problem references past problems, right? Since this is the historian theme. So yesterday's problem referenced day 2 from 2017. Corruption checksum. So why don't we solve that one? Oh, day 1 was the one yesterday that we didn't finish. We could look at that one too. Let's take a look. All right. Well, I know. Let's stay day 2. Let me grab that input. So that's 2017 2. Oh, I see what was happening the other day. I see it. So day 1, 2017. We're grabbing the wrong input. We're grabbing the wrong input. So just 2017 day 1. I don't know if we even had that input. And it looks like maybe my worksheets are not running. So this is why we get on early. We make sure that's yeesh. Okay, so some thread died while evaluating a different worksheet. And since then, let's see, restart. Let's just restart metals and see what happens. Meanwhile, let's read day 2. So, as you walk through a door, a glowing humanoid shape yells in your direction. You there. Your state appears to be idle. Come help us repair the corruption in the spreadsheet. If we take another millisecond, we'll have to display an hourglass cursor. Okay. The spreadsheet consists of rows of apparently random numbers. To make sure the recovery process is on the right track, they need you to calculate the spreadsheet's checksum. Okay, easy enough. For each row, determine the difference between the largest value and the smallest value. Checksum is a sum of all of these. All right. In the meantime, is our worksheet up and running? So evaluating, still loading. This will be 2017 day 2. Oops. Oh, day dash doesn't exist. Let's make sure we have day 1. We don't have that directory, okay. Right, this is a year I have not touched. All right. 2017 1, 2017 2. Great, we should have both those inputs, maybe. Oh, yes, we have a leading 0 prefix in our names. All right. Cool. Let's look at day 1. And this is super easy. 1029. Okay, just to recap for part 1, what did they want us to do? A CAPTCHA, sum of every digit that matches a digit that's to its right in the list, where the list is circular. Okay, so for part 2, Progress bar that jumps to 15%. Apparently the door isn't yet satisfied. Instead of considering the next digit, it wants you to consider the digit halfway around the circular list. Your list has an even number of elements. Okay, so we just add half the length of the list, mod 1. So, or we could do it differently. So we could do input dot zip with, we'll get the left and right. I don't want to mess with the indices. Or you know what? Maybe I do want to mess with the indices. Let's do input.indices.map. So for each I, we're going to take, hey, always needs more quicksort. So I'm going to take indices I and do that with indices I plus the length of 1 input dot size over 2. Over 2 I meant. That whole thing, that whole sum modulo input dot size. I don't know if I like writing it that way, but I've already written it that way. So now the second part is just the same old collect. Wait, this is the input. Okay. $12.20. Okay, easy enough. I'm just gonna rewrite that real quick. Let's do left, right equals input dot split at input dot size over 2. And then we're gonna do input dot zip with right plus left, and then do the same code as part 1. So balance 2. Okay, I like that code a little bit better. Okay, day 2. So here we're calculating a checksum for each row to determine the difference between largest and smallest value. The sum of all these differences. Okay. So after we get the lines, what are we gonna do? So for each line, we're gonna these are spreadsheet show. We'll just do this on the thing. So valid rows equals input map. I know. Let's do it this way. Split with space. And let's just peek at the input. I want to make sure it's just one space. Oh, okay. So there could be multiple spaces. So regex will do space plus, and then dot map. So for each of those, we're going to parse it to int. And the difference between largest and smallest values. Let's make this a list. Rows.map. So for each row, we want the largest. Row.max. Let's just assume that none of them are empty. Row.min. And then sum of all of those. This is and one. Some of these are two. Okay, so after we split, we missed some of these. Are these tabs separated? Okay, we'll just do like white space. Is it /W? I need to cancel it twice. And we end up with some empty strings. What is this? We'll just open it. Day-02 from 2017. Okay, there are indeed tabs. Whatever, we just copy a tab over then. So we're just gonna split on the tab. Great. It's a little bit devious. So 39126. And part 2. Um, based on what we're seeing, evenly divisible values in the spreadsheet. Okay. Find the only two numbers in each row where one evenly divides the other. The result of the division operation is a whole number. The only two numbers. They would like you to find those numbers on each line, divide them, and add up each line's result. What do you mean divide them? If one evenly, oh wait, one evenly divides the other. It's not necessarily even or anything. Okay. We could just do this n squared for each. There aren't that many values. Let's see, let's turn off Copilot here. So given a row, and I'm gonna do, oh wait, Copilot, there we go, disable that. Okay, so for an A in row and for a B in row, if one even divides the other, so let's say A mod B is equal to 0. If A mod B is equal to 0, we're gonna yield A divided by B. Yeah, that's good. And what are we going to do with this? We have, it's going to be a list. So we're just going to get the head there. Just go into ints and do ints.head. And we do that for each row. So rows.map, find evenly divisible. And there's always going to be that in row. Yeah, and some. 16. 16 seems small. Oh, you almost overslept. 5 minutes. Have you had your coffee yet? Good morning. Good morning. 4, 3. Oh, we have an Eric Wastel in the house. Okay, what are these numbers? We always get one. If A mod B is equal, oh my God. uh, yeah, if it's the same number. So if A is not equal to B. Okay, that list should be much shorter now, much shorter. So 258 sounds more like it. Yeah, back to 2017. This is the problem that was referenced yesterday. So I'm going over all of those. So I just did day one and day two. You don't have much time for another one, but let me at least queue one up. Okay, so this was referenced from some problem. 2024 day 6 references. Wait, that's not right. 2018 day 5, which I already did earlier this season, in fact. Okay, day 7 references the rope bridge from 2022. That was a fun one, but it's also already done. I have done the encode puzzles. Those were my favorite, 2019. The problem from 2 days ago reminded me of the encode. So I was happy to see that. Okay, 2024 day 8, reference 2016 day 25. That's one I've not done. Cool. So this will be the next one we warm up on. Good luck, Michael. And Sparkly Dark Matter, good luck. Good to see you come back. How far are we? 3 minutes ago. Well, let's read this problem. Just to see what we have coming up. Maybe I'll do this afterwards if today's goes smoothly. Huge antenna. Service number on the side of the antenna. We need a clock signal. Timing information to the antenna. Computer knows how to read the data you're sending into it. Okay, right. Ones and zeros. You ask if the antenna can handle a clock signal at the frequency you would need for the data from the stars. Assembly. Oh, wait. From day 12, we extracted the antenna's clock signal generation assembly code. I might have to do assembly. Assembly, that sounds fun. Okay, so we'll do assembly leading into day 25. Okay. And that one relies on other past puzzles. Okay, so I'm gonna have to climb that tree. That will be a fun one to dig into. All right, there's my 1 minute alarm. Time to get ready. Arrow bounce, good morning. Good luck, good luck. Okay, we'll take day 18 and save that as 19. All righty. How many reached 500 stars? Yeah, I'm curious to know how to. And I wish I'd be part of that club. Not till later this year. I'll at least get it by the true 10th anniversary. Only a few hundred. Okay, day 19. Um, okay, we might visit the onsen, arrange our towels, they'll let you in for free. So they have pattern of colored stripes. Okay. Uh, Branding expert has produced a list of designs, which is a sequence of stripe colors. Okay. All available patterns and list of desired patterns. Okay, so these are available patterns, and this is what's desired. Okay, so do you have to contract the desired from the available? The first line indicates that the available towel patterns in this example. Okay, remaining first case of Watson. Okay, yeah, makes sense. So BRWRR can be made with BR, then WR, finally R. Okay, so I feel like this will probably be an optimization puzzle. Um, this might be one where I make a slow version of this just to test the optimized version against it. And once they match, then I do that. But I don't know, I don't quite know yet how I will do the optimized version. Uh, 6 of the 8 designs are possible. How many designs are possible? Okay, well, let's look at the input. Okay. Um, Probably some amount of searching. Maybe I can make an index. Each of those, which ones do they show up in? That maybe won't be too hard. And then for each of these, we look at all the ones that show up in it. Um, and we try concatenate them, try assembling them in some way. Okay, we'll start with an index. So val desired equals at input line 0 split at comma space. Maybe I'll make a list. Okay. No. Those are the available patterns. Okay. Yeah, available. So we'll make that set. All right. Thank you. Thank you. Thanks for stopping by. Now, desired equals input dot drop to dot to list. Okay, val index. So we're going to take for all of our desired dot map, and we're going to take our available and we're going to filter from there. That filter, there's some A segment, so we're going to do the dot contains slice, or wait, substring. No, that's not Boolean. Yeah, contains slice. Okay, and we're going to do D to that, and to map. Okay, We have an index. Now what do we do with it? Um, so we could search by trying to remove substrings repeatedly. So def possible. So we have a D. That we're checking if it's possible. And this could be recursive. This could be, I wonder if there are a bunch of repeated patterns. This could be memoized. Um, and then we have our A's. So a set of string. What's the safest? Take out the smallest first, take out the largest. Um, yeah, I'm feeling like my first approach here is going to be checking all possibilities, like choosing one to delete, and of course we'll be checking each of those, each of the remaining bits. I might do that with intervals, just so it's more optimized. But before I decide to search that way, um, let's look at available patterns at size. Jeez. And okay, there would be 400, 500 to search from normally, but um, index dot values dot map size. Okay, on average, these are significantly smaller. Yeah, maybe that index is the advantage that we want, and that's enough to make it work. Uh-huh. Okay, and we'll use ranges and diff. Import OC interval. And have I have a search. So def search. Given a string, this will be the recursive bit. Can't ever go down too far, right? Because how long are these on average? Not so long. Um, and I guess this can just be, I'm just going to return Boolean. Instead of D, we're going to do an interval. So end, search within an interval for an A. Okay. So I guess the size of the interval might matter. So we'll start with that. If A dot size is greater than or equal to N dot size, then, oh, whoops, true. Or false. We'll just say greater than. You got 854 for part one. Okay, awesome. Nice, sub 1000. Maybe I'm overthinking optimization here then. I should just do like full n squared try construct these. Maybe instead of checking each of these, I should just start constructing. That was fast. Nice, well done. Otherwise, d dot slice from n dot min to n dot max plus 1. I hate to have to do a plus 1. That contains a. Or rather d dot substring. No. Contains slice a. Okay, if it contains it, we remove it and then search recursively. So val left equals, well, let's get the index. Val I equals d dot no index of slice. Oh, I should just do that. So let's do index of slice. Okay. So val I equals that. So if I equals -1, then false, right? Otherwise, we remove and search recursively. Left equals. And take and that drop. I'm not gonna mess around with intervals. Let's just do a D string here. So 0 until D dot size. Okay. Oh, we don't even need to. We just use our D because D is already a substring. Okay. I'm not sure if this line here is even a necessary optimization, but we'll leave it there. So val left equals n dot drop I. So we'll search 0 or rather a dot Baka streamer is now following. Thank you, thank you. So we're going to search recursively with a substring. So d dot substring, and we're going to search recursively using a full set of a's. So let's do that. A's dot map. I guess we call this B because we don't want to clash in names. Last single variable names tonight are single letter names. So for each of these B's, we're going to search d dot substring from 0 until I. Yeah. And just to verify, is the end index inclusive? Let's give that a test. So steward.substring. Say 0 until 4. Okay, it's not inclusive, so the index 4 is not going to be there, right? So left needs to, the search on the left needs to pass. Val left search. What's that? Val right search equals A's map. Now we search a different substring, which will be I plus A dot length up until D dot length. So left search and right search. Now the one thing we haven't considered is maybe this particular A appears multiple times in there. And maybe we are supposed to split on the right one, but not on the left one. In which case, I don't know. We'll cross that bridge when we get to it. To do multiple. Missing a parameter. Oh, right. We need to pass in that B. And you're all done. Rank 1074. Hey, awesome. Well done. Well played. I think that's the fastest I've seen you solve anything. That's great. 14 part 2. That's a good one to work on. And drop D touch. Wait. I don't even need that left. It's not a member of set boolean. Oh, I guess we do an exists here. Okay, and then we still need to check all the places that string might occur. Okay, and we start this off by doing a search with D and any string. So we do A's that exist on A such that searching D and A works. Okay. I feel like this whole bit of checking all the A's should occur elsewhere. And this should maybe not be a parameter here. But we can refactor that later. Okay, so we're gonna do, I guess we do index dot available. There's a possible one. Or wait, that dot map. See which ones are possible. Or count. We're counting how many are possible. So this should get us a count, right? I think it'll be too low. If it's fast enough to run at all. Okay, let's cancel that run. 20 seconds is too long for me. Um, oh, possible could be the recursive, this could be the recursive call, just possible. So we don't need to define the search with just an A. In fact, this whole thing can just be um, possible with A's. Yeah, being passed in instead of each individual B. But whatever, it's too slow. Let's see if it's at least even correct. Day 19, 2024. Okay, we'll give that a shot. Oh, and do we even have a base case? Yeah, we check the size. Then it won't recurse. So this should return 6. Um, it's possible we have an infinite loop. Oh no, we haven't even changed. Hold up, hold up. Hey, Hellhound, welcome. Are you starting the problem late too? Did you have meetings today? This kind of pattern matching is a pretty realistic tactic that occurs at work. Yeah, I feel like do you know the site Rosalind? I feel like Rosalind would oh, hold on, that's making me think. So I've gone through Rosalind before, and it has a lot of problems that are sort of like this. Let me drop the link. So rosalind.info has a bunch of computational biology problems or bioinformatics problems. A lot of like string matching finding like this. So I think, is it this? Yeah, like counting nucleotides and substring search. And some of those require some good optimization, but it's been ages since I've done this, so I'm forgetting whatever I would have done there. I know one thing you could do. Well, see if it's possible to reconstruct. Yeah, it would. This would exactly be like a bioinformatics problem. Medalim, hello, welcome. Yeah, it seems like it's gonna be another easy day. Are you done as well? I'm not done. Um, okay, so we failed to evaluate. I should just do this the other way around. I'm just kind of checking this top down and checking if a string is possible by splitting it into, I don't know, finding a substring that exists, splitting it left and right. But I'm realizing that there may be too many. I could also try reconstructing it from individual segments. Oh, hold on. Do these have to? I might have had a big misunderstanding here. I was thinking these have to be like spliced directly together. Um, uh, um, let me see. What I think, can you like cut the existing towels? No, I mean if you could, then you could just get everything. Available towel patterns. First, ta 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 ta. How is a thing possible? You can use any tiles you want. All of, you could use two RG tiles, an R and RGR, or even a single massive RGRGR. So right, it's just juxtaposition. Like there's no overlap, right? So to make an RGRGR, you can't use two RGRs, right? Yeah. So if you arrange your tiles, I believe you. I believe you. Yeah, I'm probably overthinking. Um, maybe I don't want this approach at all. I could just search permutations. Well, actually, there are a lot of permutations. Okay, I mean, how about this? We just start from the start of the string. We're not going to search for substrings anywhere inside. That's silly. So we're going to scrap this for now. I believe you. I'm overthinking. Um, yeah, so def possible as a single tile possible. Um, and we can just do this recursively by stripping off any that match, any of the available that match. So Boolean. Okay, so we're gonna take available. I think we want this to be a list. Yeah, I mean this index to be a two set, two list. Okay, so available dot filter t dot starts with, or you know what? We can combine that. We'll do available dot collect all a such that case a if t dot starts with a. And then what will we do? We'll do t dot prefix strip prefix of a. And then that exists possible. Okay, there we go. This is my part one. Val ends one equals input dot count possible. Okay, as dumb as it gets. Now try to think about optimization. Okay, there's a bug in there. Da, 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 da. So available to collect all available ones such that T starts with it, right? And then we recursively check if that with a prefix stripped is possible. Okay, so we're getting a 0. What is my available? All of those. And these are my desired. Oh, no, not input.count possible. Desired.count possible. Okay. Let's just check. So possible are, so that should be possible. False, even though the A has an R. Oh, wait, we don't have the empty string. So if T is empty, well, let's do this. T dot is empty, or then do this. Okay, so that should work. Yep, that works. That works. Super easy, super chill. I was overthinking. Definitely. This is like basically a one-liner. Or at least it's a one line to write something that's not optimized. We could optimize this further by not actually computing a prefix. We could just do an index. Okay, great. So our dumb version works. We'll keep that commented out, but we want a better version. So we'll use indices from an int, and then I guess def possible. Oops. It's just going to be possible t from 0. Okay. So now we'll get, I don't know, we'll filter such that available that filter t that starts with, and if it starts with that a that exists a such that possible t dot no still in t, but now we do the index is from plus a dot size. Okay. Yeah. I'm just gonna do it this way so I can. Okay. In this case, oh, we're getting Stack Overflow. This is not tail recursive. How is this not tail recursive? Oh, because there is this is empty, so that is not tail recursive. But it should work for the example, right? 6. Nope, it's tail recursion doesn't matter. It's just an infinite loop. So possible t from, oh, we don't do t as empty. It's always going to be false. So from is less than or equal. No, we'll do this. Less than or equal to t dot size. Equal. Yeah. That gives us everything. Oh, no. Let's make this a condition. So let's say from must be, make that an and. And what's the condition we want? So it has to be true that less than or equal to less than t dot size. What I do, so we filtered available for ones that t starts with, and we take that string and we search recursively with a new from index. Eric is rewarding us for day 17. Day 17, part 2. It was beautiful. That was a fun day. Super fun. What am I thinking? I'm thinking that somehow I don't have a. Oh, Michael, did you finish too? I am I was overthinking at first. Yeah, part one uh does seem easy. Um, so T is empty. So if T equals, let's say from equals T dot size, there we go. Or, so if from equals T dot size, then it is possible. So this should go to 6, 7. No, that's not right. No, I'm not done with part one. I know, right? I know. I started by overthinking about, worrying about optimization. I made an index and started doing this dumb recursive function. I was overthinking it. And I wrote this one liner. It took, I don't know, it took like a second to write it. That works on the example. And just now, as refactoring that with an optimization, use indices instead of actual substrings. Um, but maybe I should just let that run. I mean, people are saying it's stupid easy, then I don't need to do an optimization, right? But if I do need to do an optimization, what other things can I do? Okay, I have a super dumb, easy optimization that's easy to add here. Instead of doing available.collect, we'll do index.t.collect. So that's a subset of available ones that actually appear as substrings at all. Okay, great. So key not found. Oh, hold up. If we're gonna do it that way, we do have to search using an index. So we'll have to do this approach here. I don't really want spoilers. If I'm doing something stupid, you can ask me a leading question. Um, but I mean, I don't think like this is a hard one, right? So I'm just gonna do this from, yeah, I'm just gonna do this with the index version. Let's make this index version work. Okay. So we have a recursive function. Hopefully this is tail recursive. Oh, hold up. Tail recursion only works. Object tail rec. Okay, in a worksheet, tail recursion doesn't work unless it's inside of an object. I don't know the technical reasons for why. So if from is equal to 0, then by default it's true. Then true. Else we do available, we filter t that starts with, and we don't need to do available. We can do oh, hold on. We don't want t that starts with. We want to search using our from index, so not starts with. So that was my bug. But t dot substring, no, index of slice. And index of slice can take a second parameter saying to search, yeah, from. There we go. We pass from along. So given this a, okay, filter such that the index of slice is not equal to -1. And just because we had the index, we can do this optimization as well. So where we have index t, yeah, index given to t. We want Tail rec dot possible. Okay. Now we just do desired count possible. 400. No. Okay. We have a bug. Let's check that this works on the example. Oh, we're back to 8. Um, okay, this one here that wasn't working. Was it not? I think it's not working because it was slow. Um, call this naive possible. That we can leave it uncommented and use it for testing. So, oh, we broke naive possible. Wait, that was working before. What did we change? Oh, exists possible. We want to use exists naive possible. Um, I don't know. Naive possible is working. Let me make that tail rec. Hmm, Taylor. Oh no. Uh, okay, let's just try this out. T strip prefix, then we recursively pass that new T, check if it's naively possible. Um, and we could also we can optimize this. My index version apparently, I guess, has a bug. Wait, is this running? Um, oh, there we go. Now it's running. This always kind of gets me when there are multiple evaluating at the same time. Okay, what else is there? I mean, I could build them up. I can get this to fit into naive possible by defining like a tail recursive search within here. Yeah, let's just optimize this one by using indices. That's not like an order of magnitude optimization though, so I don't want to do that. It's just a constant. So we're not going to worry about that particular optimization. Um, we just need a different algorithm. Oh no, using the indices is tail. Uh, okay, it is an order of magnitude because you have 70, right? The size of this. You have like 70 of these versus 700 of the available. So let's define our naive possible. Um, by implementing, let's say we have a recursive search in here. Boolean t string. Okay. So exists search. And we'll just call this possible. So count possible. Now val a's equals index of t. Okay. Then you search within the a's. A's dot collect. Case aft dot starts with a. And we strip the prefix and do a recursive search. Great. So that should work 6. And let's try that. Wait. Let's make sure it actually does work on the example. It doesn't seem to be updating. I'll just restart VS Code real quick. Yeah, I mean, this feels pretty standard. Yeah, y'all don't have to tell me how easy this one is. Uh, this admin of code that everybody's doing is a programming challenge in the form of an advent calendar where a new 2-part puzzle comes out every night. I'm just gonna move this stuff out of the way. I don't want to be looking at that failure. Whoops. Oh, def search. Declaration of the method search is not allowed here. That's nonsense. I don't believe that. So we search within T. E is empty or A is a collect exists. Search. And I'm not sure if this or results in tail recursion. I think it should. Yeah, about 200,000. It's really fun. Here, I'll send you the website so you can take a look. And right now my worksheet's just not running. I don't know. Let me debug here. It says the worksheet evaluated. Oh, here we have that relation of method search is not. I feel like this is a syntax error with a bad message because this is totally allowed. You can totally define a function instead of another function. Um, I don't believe that. I don't believe that that's a thing. Fine. Let's do A's. Set a string. Ooh, we don't want to do this with a set. We don't want to collect with a set iterator. Collect. Exists search. Okay. Fine. We'll do it this way. So search is now a helper method. And just so it's tail recursive, we'll put that in an object. So we'll do tail rec dot search, and we'll pass in. Whoops, what happened here? Tail rec dot search takes some A's. parameter. Okay, so that should speed it up by a factor of 10. Declaration of method search is not allowed here. It's not allowed in, no, you're allowed to define methods inside of objects. I'm fighting with, oh, hold up, I see. It thinks I've just declared a method because I forgot an equal sign here for actually defining a method. That's what's going on. Okay. So we search in that new thing, pass along the same A's. Okay, we are back to a running worksheet. Back to something that even compiles. Man, okay, missing an equal sign like that should give you a more helpful error message. Now I know what the error message means, or could mean, that, hey, you forgot your equal sign. But by day 19, it's not that much anymore. Most people do the first, yeah. Yeah, we could look at the stats. Oh, right here. By day 19, geez, not even 5,000 people have finished the problem. But over 200,000 have finished problem one. Let's look at the past year. So 2021's first year I did. By now, 12,000 people have finished 2021. And about the same number of people did finish the first problem. Hmm. Although I guess 25, you only get 25 if you've solved every past problem. So that has an additional constraint. Okay, back to whatever's going on here. My worksheet timed out. Okay, well, that was something where I thought, okay, index.values to list. That's something that I thought would be faster because we were searching, I don't know, like a much smaller, turn this back to the example. Because A's here is much smaller than the full set of available. So I thought that'd be an order, like, an order of magnitude. So like 10 times faster because it's only a tenth of them that you're searching. But I guess I need another optimization. Do I really need another optimization? It's an easy problem, right? So it shouldn't. Okay, maybe I'm missing something else super basic. I don't know. Maybe I should go back to finding out if something is a substring. So if t starts with a, we strip the prefix a. I mean, that's fine. Geez, do I need a nudge? Okay, so whoops, I'm gonna do dot map dot size. Okay, so these are the sizes of these lists. Oh, at least there. Let's do it in the real problem. Yeah, so here we're searching 77 as opposed to, let's sort it. That's sorted. As opposed to available that size. So normally we'd sort 447. Here we're doing between 52 and 100. So at least 5 times faster, maybe 10 times faster. But it's still not under 30 seconds. So how can I make it even faster? without really overthinking. Um, so suppose I'm trying to make RRBG. We try stripping R as a prefix. Maybe I make a tree. Um, let's make this A's that we pass in a list. And maybe on a recursive call, we filter. Does filtering it make sense? Is that filter T that contains slice? I mean, it should really not have changed that much, except for maybe that the one we found isn't in there anymore. So that filter I don't think really makes sense. Okay, let me just think about what even is the complexity of this. Um, we have like 50 of these, and each time, each loop through, we go through 50 by I don't know what's the average length of these compared to the string, right? It's not going to be made up of more than 50 of these, right? Um, let's look at our inputs. So our desired strings are not that long. So if the average length of one of these is 5, I don't know. Then this can recurse like maybe 10 times, right? It'll recurse maybe like 10 times. And each time it's looking through like 50 or 100. Okay, so we're doing this like 100 times. And then we have the number of desired that we're searching. Okay, so the complexity of this is not that big, right? I'm not crazy. Desired dot size. So yeah, there's 400 of them. And um, desired not map. Get the length of each of those strings. That's sorted. Uh, we'll do distinct. Okay, between 40 to 60 in length, and available to list. That's sorted. Um, wait, that map length. That's sorted. Maybe we map length first. Okay. Is available on list. Okay, need distinct. That's sorted. Okay, so they are 1 to 8. So in the worst case scenario, we have a bunch of ones, right? So we have to go by the full length of this. So 60. Yeah, let's say we have 60 iterations deep. Um, 60 times we are doing t that's prefix a in the worst case scenario, because that's the largest t. And we are checking t that starts with a for how many possible different, uh, not exactly 400 of them. So 60 times 100 times 400. Okay, so 2 million operations, and our operations are this. So 2 million times we're doing this starts with check, and possibly the strip prefix check. I would think we can do 2 million times in a reasonable amount of time, right? Hey, standard pointer, how's it going? Do I have rates turned off? No, I don't. Um, I get rated every now and then. Why do you ask? Did you finish up? Are you thinking about rating me? Standard pointer, how's your AOC going? This is an easy one, right? So the largest one of these is 89. We can be explicit here. So, we have 89 times the length of these available. Could go down to 1, so it'd be just like the full length. 60 times 89 times 400. I mean, it's still 2 million operations. We could do, so we're doing, starts with 2 million times. We're doing strip prefix fewer times than that. I mean, how many of them could possibly match? Like, how many of them start with the same letter? Let's say 6 of them start match somehow. So a sixth as many times as that, we're calling strip prefix. And those are really the only things that cost any time. We are unable to rate at this time, but works for other channels. I don't know what that's about. Hmm. Maybe I'll just take a quick peek at my Twitch settings. I might have been messing with like moderation settings for my channel at some point. Hey, there's a raid. We were just talking about that. Tony, welcome. Use Gemini to solve today. Okay. Apparently I can't even do what a Gemini can do. Because I'm getting, so I have here a dumb implementation, right? It's just this. It's just this recursive function. Super easy to write. But I'm having performance issues with it. Like it doesn't run in 30 seconds. So maybe I'll just run it. Uh, awesome. Intensicode, Hananixia. Welcome, all you raiders, and Fern Baby. Tony, did you get the sleep you wanted last night? Um, so here I was just wondering why mine takes so long. And so I calculated it. And this is my worst case scenario here, is that I'd have this many starts with operations, this many times this line is run. And I think I should be able to do 2 million lines. I should be able to do this 2 million times in 30 seconds, right? We have gigahertz processors, and each of these operations shouldn't take you know, more than 100 operations itself. Okay. Instead of doing starts with, I could pre-compute like an index. Um, right? Like make a hash set. Uh, or even another way, I could pre-compute the all the indexes, all the indices where A occurs in each T. And then we don't have to do this starts with check. We can just check, those indices. Yeah. Yeah, I'm working hard, yeah. Got great sleep. Good to hear. Oh, Plant Kenny was lurking. Hello. Hello. Um, okay. So I'm just gonna let this run for longer than 30 seconds by running it here in a REPL. Mhm. Okay, we'll let this run in the REPL in the background. That will run for longer than 30 seconds. And in the meantime, I'm gonna do an optimization here, the one we just talked about. Am I on part 1 or 2? I'm still on part 1. I know, today is an easy problem, but today my brain's not working. I'm gonna feel pretty dumb once I get it. But let's do an optimization. Um, Instead of making this a set, I'm doing better than you are. Well, you can still go to Gemini and ask Gemini how to do it. Okay, you did it with brute force. I'm basically sort of doing it with brute force, right? Like, there's not much I'm doing here as an optimization. I'm checking if the string starts with one of the available bits, and I'm passing like a subset. So instead of checking if any of the available ones is the start of our string, I check if only the ones that were found as a substring within the string are the start of my string. So that's like maybe 100 of them instead of full 500. 100 at most, 89 at most, actually. 55 to 89. So I'm only checking that number of these and checking if each of them starts with, right? So surely, that should be performant enough. Oh, we didn't. Oh, is that so? Unless what's going on here? T dot is empty. Is that my base case is bad and it's actually going on an infinite loop? Maybe I hadn't considered that, which that would make me feel stupid. Um, so let's check. Is there any way this can continue infinitely? So T is empty, sure. But if none of these started, so T can't start with A unless A is shorter than T, right? So this would also go false. So maybe T is not empty. But if this one is false and nothing starts with, then this should terminate. So I don't see how this would infinite loop. We could do some like print line debugging, I suppose. But this is running for well over 30 seconds. And that doesn't make sense to me, given that we're only doing at most 2 million operations, or expecting to do at most 2 million operations. So I'm going to halt that. And we're going to find a bug by adding a little print line in here. Make sure T is getting shorter every time. Um, maybe want a depth parameter. Yeah, let's do a depth. So print line, so S, do the depth, and then D. Make sure we're going deeper, and it should never go deeper than 60. Ta, 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 ta. And what else? So depth, every time we redo the search, we do depth +1 when we iterate. And our depth starts at 0. Um, okay, so why don't we try this? Mm. Can you explain what you did? Um, yes. Well, let's see. I don't want to be spoiled. I do want to be prompted if I'm doing something stupid. So, if there's spinach in my teeth, tell me. Kill Java sounds about right. Yeah, I don't know what's still running. I should just have that as a cron job. Every 10 minutes, just kill all Java. It is a very useful command. Um, but you should definitely post your solution link or in the chat, so at least other people can check out what you did. But I mean, you said you basically did brute force, right? I had a couple of brute force like for loops to make it happen. And I'm essentially doing a brute force here. I mean, I guess I could brute force in other ways. Instead of destructuring my the towel that I'm trying to make, I could try to build up for my segments instead of like knocking off segments from the front of the desired. But I don't see that would necessarily be faster, right? And even then, it still perplexes me that this isn't fast enough. Like I'm pretty sure I did my calculation right, and that this is the maximum number of operations. So what I'm still suspecting that somehow my code's just not doing what I expect. Okay, yeah, n factorial because you check all the permutations, of course. Um, oh, what's going on here? Okay, so it's never gone over 60. But what is this? Um, why are we never seeing like smaller numbers? 30. Are we looping? Okay, so this is how far we are in. How many? And then this is the size of the string. Why is the size of the string always small? I guess because most of them are small. Let's scroll through this slowly. Okay. So here's a case. Oh, whoops. Oh, come on. No, don't do that. Okay, I think my terminal has like limited output. Are we seeing the same things over and over again? We are. We're seeing the same things over and over again. Okay, so we have some sort of infinite loop then. Yeah, these look super familiar. Okay, so why do we have an infinite loop? Okay, so when we had the string BGGUR, let's search that in our input. Okay, I think we're actually onto something. And by onto something, I mean we're onto like what our bug is. Okay, so we keep going in an infinite loop with this string here, a few of them in. And what happens? So if t that starts with a, so I'm going to comment this out, and I'm going to try this one. Whoops. And we're just going to tail rec that search. Or no, we're just going to check if that is possible. And this somehow results in an infinite loop. Do we have an empty string? Is there an empty string here and available? No, there can't be an empty string. And I know that because we did available and we got the length of each of those strings. So the length of the strings go from 1 to 8. Okay. So this here, okay, we do tailrec dot search for that t given just all the available ones. And of course, depth starting at 0. Okay, so this results in false. Okay. So that was a string that we kept seeing over and over again here, right? BGGUR. URWRW. Okay, so we've got a weird bug here. Okay, if anyone finds this bug and figures out why this is happening, I'll be impressed. So you're super welcome to backseat here and try to find out what's going on. So when I search straight at that, it immediately tells me it's false. But when I search here, it ends up reappearing over and over. And is it always the same depth each time? No, it appears at depth 24 and at depth 25. I mean, suppose I memorize this. I could memorize it. I don't want to. Like maybe we're getting to this in multiple ways. And if so, we could do a dot distinct. No, I mean, we wouldn't get to it in multiple ways, at least not in the same thing, because these A's should all be distinct already. Let's try a slightly longer one. So what are these longer ones we're seeing? RGUR before it. So RGUR. Okay. Maybe it's not an infinite loop, it just shows up a lot. Well, the pattern we see here is it consistently gets smaller, right? But we do see it happening over and over again. So I think this might be a case That is like still more lines I'd like. So I think I would like to memorize this. But do I memorize it specifically for that sub? I guess I would have to remove this particular optimization. Yeah, let's remove that optimization. Let's just do our old, more naive approach with memoization, right? Yeah, let's try this. So with memo, val memo equals, I don't care about this index version. Yeah, index won't save me. That's like a constant time factor. Collection dot mutable dot map dot empty, and it's from some string to a boolean. So we'll just call this possible, and we do memo dot get or else update lazy val calc. Okay, so we get the t. Otherwise, we do. Oh man, didn't I mention like near the start of the night that one of the first things I could do to optimize it was to just memorize it? And I never got around to memorizing it. I don't know. I forgot that I wanted to do that. But let's see. Let's see if this does it for us. It's not that we end in an infinite loop with this. It's that this just appears too many times. It does feel silly. Okay, val memo like get or else update. There's T and calc. Tailrec is already defined. Whatever. Okay, and we do tail. Tailrec dot possible. Let's do desired dot count. Tailrec dot possible. Okay, there. Super easy. Super easy. Okay, and we don't need this indexed. Okay, there. That's my code. Uh, very easy to write. Geez. Okay, let's put that in. Let's put that in. Okay. Now, if you're still there, Tony, you can tell me what you did for part 1. 369. Man, okay, this should take me. This is what I had at the very start of the night, right? It took me like a couple minutes to write this once I decided to write it. So reading the problem, whatever. Memoizing it takes what, another. How long did it take to write the memo? I should get this in under 10 minutes. uh, yeah. Also, dynamic programming. Dynamic programming and memoization are sort of equivalent. Like if you can do it with DP, you can do it with memo. So I just go with memo because it's super easy to write this. Takes less thinking because I'm already using my first approach as a recursive function. Oh, early termination? Sure. Okay, but I thought, so I'm calling exists here, and exists should early terminate, right? The first one it finds that's possible, it should early terminate. but this possible is a recursive call. And I think I'll go with depth first on that. Like, I don't think this should, I don't think this will like go call possible on all the possible, on everything in the list, and then check if one of them is true. I think this should early terminate. And it could be that the runtime is much slower, but still. I know. And I even changed this here, this available to an iterator, right? If we just did calc, wait. I don't actually want to run that. No. Don't kill my worksheet. Uh, okay. Go click the link for. Okay, yes, let's get a fast delta. Um, part two. The staff didn't really like some of the tile arrangements. To avoid an endless cycle of tile arrangements, maybe you should just give them every possible option. Okay, sure. Here are all of the different ways. This can be made in two different ways. This can be made, okay. So now we count the number of ways that's possible. Add up the number of different ways you can make each design. Number of different ways you can make each design. Okay, so instead of exists, we're going to do a count. No. We're going to map possible and then dot size. And this is an int, or not size, sum. And now we do if t dot is empty, then one, else we do all this stuff. Okay. Yes. Oh, and this goes to int now. So this is ands 2. Found int. Oh no. Dot map dot sum. Okay, and we have overflow. So let's just make this long. Map possible dot sum. Let me doing 1L here. Calc is a long or int. Oh, possible needs to return long. Okay. Copy worksheet output. Okay, super easy delta. Damn. Yeah, I mean, it didn't even. So a few things happened here. Like once I started having performance issues, I should have done a print line. A print line T is enough to get like this thing here, right? And see that we're doing the same thing over and over again. And when I see that we're doing the same thing over and over again, I should think, oh, yeah. So big brain fart there, but you're right. This is super easy. Yeah, you thought you were looping. Cache fix your problem. Yeah. Oh man. I was super overthinking this. Um, I didn't know about Python cache. I do want to show. I want to show some code. Okay. So I didn't know about Python cache. So Project Euler, day 14. Search my repos. What are my repos? I don't. Project Euler. Project Euler day 15 is a Collatz conjecture, right? which is the one where, yeah, this is the Collatz function here. If n mod 2 equals 0, then you multiply it and add 1. Otherwise, you divide, or you divide if it's even. If it's odd, you multiply by 3 and do 1. So this one needed optimization, and I figured out here in Python, when you have, so these things here, so when you assign that value, this is the same value shared across all calls of that method. So I could keep my cache in there. Super short memo. I didn't know about like the at cache annotation, and that's my memoization. And this is now like permanent on the Project Euler. So if solutions get upvoted enough on Project Euler, then they end up getting pinned. So this got upvoted enough that was pinned, even though it came like super late and such an early problem where the board's already saturated. So that's how I do cache in Python. I always just put a dictionary, default dictionary value in my method. Python at cache is cheating. Wait, you call this DP? I mean, DP and memo are kind of two sides of the same coin. Ah, okay. After D myself, what I think I'd like to do is today's problem, and if it references 2023 date, oh, I've already done this problem. I was hoping it would have a reference to like an easy one that I could fix. Do I dare look? Okay, I'm somehow still top 5,000. I felt like I'd be over 10,000 today. Just given. That's definitely DP. That's top down. Like top down DP is just memoization. Okay. Can I see someone else's solution? Does anyone have a link? I want to see what these look like. Nice that we have another easy day. Like kind of sad that I didn't take advantage of it. It is 1:30 a.m. You got just 4 places before me. Just had to use cache. I know there's like an at memo annotation in some of the Scala libraries that automatically memoizes a function for you. And at this point, I mean, what are you saving when you it's not like you're I wouldn't even really call it cheating. It's super easy to just write your own memo here. So I don't think it's really cheating. Yeah, I guess not many people aren't trying to do it right at midnight. By day 19. By day 19, I guess people have burned out. You know, my best year, I feel kind of sad that I haven't improved. I think my best year, no, no, this might have been my best year, 2022. So 2 years ago. So that's in the top 1,000, 4 times. I got 156. I almost, I almost pointed in 2022, but I don't practice. So maybe this year I'll actually practice, and next year I'll be more consistent about getting under 1,000. I feel like I have the capability, and it wouldn't take much practice. It's just always some dumb mistakes. Okay, we have Icy Black Deep's code, part one with an early return. Yeah, I'd like to see that. And we have IntensiCode, the Gemini solution. Okay. Oh, why did that? All right. So this is Icy Black Deep with the early termination. Okay, parsing, DFS. Yeah, I'm pretty sure mine is doing depth first, which, like, you need to do depth first to take advantage of the early termination, right? And doesn't just return true. Sure. Cool, makes sense, and doesn't take much to change that for part two. Hey, give me 1 second, and then we'll check out. Let me pull up the Gemini code. So have a look at that. I'll be right back. Oh, thank you. Okay, well, I'm gonna call it a night. Yeah, the Gemini one was pretty verbose. I say, if nothing else, at least I got concise code tonight, so that feels good. Um, let's find someone to raid, and then I'm gonna get some sleep. Oh, Snow Cone. I've not seen Snow Cone streaming AOC in a long time. So let's say hi. Snow Cone is the reason I'm not just using solarized anymore. She made me choose a more appealing color scheme. Snow X Cone. Thank you. All right. Well, thanks everyone for your patience, for not spoiling me. uh, and yeah, thanks for sticking around this far in. Yes, she's doing past days trying to catch up, but it's a pretty chill stream, so let's do that.